Hello, folks. Hello. Yeah, looks good. So, this is just a stream that I am like working with rate limiting and exploring what's more it has to offer. So, I come across this repository, in which I think they have added various type of rate limiting. Like, I was just exploring it and found like this has fixed window, leaky bucket, sliding window log, and token bucket. So currently I have a hardware issue, which due to that, like I cannot run Redis with Windows subsystem for the Linux. But let's see what we can do in my current repositories that I have. I'm sure I may be able to do something with the help of ChatGPT or any other things. Mm. Hmm. Let's see what we can do about it. So basically, in the last stream, I have issue with that MongoDB and it was it is. So I fixed that and added a simple rate limiter with this. So it's working perfectly. We can probably see this in my repository. Let me pull this up where I put in my packet JSON. So this is the URL. I think I will make sure to put this repository in my description later. So let's see, a fixed window and sliding window log. Like there are so much to look at it. So generally, rate limiting is the concept to like abuse of uh, resources like API calling or hitting too much. But I realize this that there are so many pattern exist, so there must be in past a few people have exploited them, right? So let's start with uh, implementations of it. Let me actually create one branch specifically for rate limiting experimentation. I believe it is necessary for the experimentation of rate limiting. Like, I want to know what kind of problem does this like solving it, and how can I leverage it into my real world programming? And you can say that's what I really want to know. Let's do this. Rate limit. So I can happily like experiment to my heart's content from this branch. Now, I think I will start with the fixed window rate limiting. Mm. I have a sore throat, so you have to like bear up with my voice if it's breaking too much. Let's see, while it's happening, we can have our water break. Okay. Okay, so let's work with applying fixed window rate limit. So generally, I think what I think is that the rate limit we have applied is also the form of fixed window because our window size is 15 minutes, and in 15 minutes we are only like giving him to chance out three requests. So let me uh, reduce this to let's say around let's give him in 1 minute. I would like to give him a chances of, let's say he can make 15 requests. Yeah. So fixed window. Okay, so actually let me have back and forth conversation with ChatGPT. Okay, so I would like to experiment here with all the various pattern of rate limiting into my project, and like to I would like to start with fixed window. Yeah, my current uh, implementation. Let's actually give them our implementation and also the doubt that we have been forming in my mind, that the current implementation is nothing more than like sort of like fixed window. Let's ask them as well. So this is my current implementation, and I have used that in my route like this. Let's give them a route where I have used this. It was in my link route, and this is how I have used here. So I have doubt here that isn't this is just the form of fixed window pattern, just a simple rate limit for fixed amount of time that we define in rate limit config, or am I something missing here? Hmm. Let's see. You are actually noticing something important here. Yes, what you are using is a fixed window rate limiter. I thought so at much because it's in its name says fixed window. So, like in the limit of window size, we have defined it. It's a 1 minute fixed size, and the max for per limit IP 15 requests a person can send here per 1 minute, right? Okay. Uh, let's walk through it like we would during a design. Then this part is how it's implemented under the hood and what changes when you have moved to Redis. Let's walk through it like we would during a design review. What your middleware is doing is const limiter. Yeah. This literally means every 60 seconds allow at most 15 requests. If we imagine a timeline like window 1, 12 to 12:59, this one 15 requests allowed. At 12:01, everything resets. Another window begins. Window 2, again 15 requests allowed. This is exactly what a fixed window algorithm is. Under the hood, memory store without Redis. Express limit stores something conceptual like this. Express limit stores something conceptually. That's mean express rate limit store without Redis. So I have a question. Where exactly does this count stored here? So let me show some it like this. So start writing. Ask ChatGPT. So without the need of Redis, where does this actually store? In memory or where exactly? Like how it even track the counter of that? And also one thing that I noticed is that actually let me pull up my Postman, and I didn't see the count anywhere, or maybe I missed it in my like headers or something. The send it, I guess. I didn't see the count anywhere like in header when I was hitting APIs in Postman. So here is my postman, and I think it should take a while to load up. Let's see, each request receives request, look up the IP, allow. Oh man, it's gonna block everything. Shit. Well, anyway, nothing I can do now. Mm, let's see if I can move past it. Okay, great. Look up IP, increment counter, counter greater than max. Yes, then it will give me 429 error. If no, then continue. When the window expires, delete the counter or reset to zero. Worked example that I can say, suppose window is a 60-second and max is 5 times. Timeline is 12, counter 0, request 1 hit, counter incremented, 5 allowed, request 6 rejected. Nothing fancy. Then exactly at 12:1, counter reset to 0 again. Why is it called fixed window? Because the window boundaries are fixed like this every 60 second, not like this. Those sliding windows move with each request. Fixed windows do not. What changes when Redis is introduced? Almost nothing conceptually. Instead of memory store, you use Redis store. The algorithm is still fixed window. The storage changes. Instead of a map, you now have a Redis user key value pair. Okay, so they have given me a work Redis example. So I will have an increment. This is some kind of command or key rate limit. This is a variable, and this is the user's ID or something. For that, I am storing the result 1, expire time 16 seconds. Okay. 3, and eventually rejected. Next request, brand new window. Then why do people say fixed window is bad? Because of the boundary problem. Imagine window is equal to 1 minute, max is 100 requests, timeline is 12:59, user sends 100 requests, allowed. 1 second later, window resets, user send 100 more, allowed. The server just processed 200 requests in about 2 seconds. Even though your limit says 100 per minute, this is the biggest weaknesses of fixed window. Why sliding window exists? Sliding window asks how many requests happened during the last 60 seconds instead of how many requests happened during this calendar minute. That tiny wording difference completely changes the algorithm. Okay, so it keeps track of the interval, right? The 60-second interval. I don't care about calendars. I just care about the last 16 minutes. What happens during those? So that is the core concept of sliding window, I guess. Okay, okay. One thing I noticed in your middleware, you brought will take IP as greatly. This is So the limiter only knows the client's IP address. It has no idea who authenticated user is because authenticate GWT hasn't run yet. If your intention is each logged in user gets 15 requests per minute, then the order should be authenticate JWT should be first in that. So what I will do is here, let me put something like this. Mm, So, authenticate JWT is gonna authenticate first, then I have a limiter, then controller, and you would configure a custom key generator, for example, key generator request user ID. That way, the rate limit is tied to the authenticated user rather than an IP address. This is a common production pattern because many users may share a single public IP. Okay, office schools, mobile carrier, entity, and link by IP alone can even unfairly trouble unrelated users. If I were turning this into a learning project, oh, this is not a learning, fixed window memory, I would implement each algorithm myself in increasing order of complexity. Fixed window, that is what I have done. Redis part has also done, I guess. Fixed window, sliding window log, okay. So answer this and then I would like to move on implementing sliding window pattern. Excellent question. This is exactly the kind of curiosity that leads to understanding how these libraries actually work instead of treating them as magic. Where does the express rate limit store the counter if I'm not using Redis? By default, it uses an in-memory store. Internally, when you don't specify a store, express rate limit creates a memory store. Conceptually, it's something like class memory store current is equal to new map. The library, uh, so hmm, this package itself creates something called memory store, and in that I have current is equal to new map function. The library maintains this map inside your Node.js process. Imagine your server starts at this node process express route variable memory store map. As request arrive, the map grows. Let's say this every request simply updates one of these entries. Suppose window MX is 60 seconds, like 60, yeah, 1 minute, MX 5. Incoming IP this map before this map has IP, no creates one. Second request same IP, sixth request. That's literally all that's happening. So where is this map stored? If your Node.js process memory is not MongoDB, oh, say. So generally, it is stored in v8 heap, just RAM. Like if you wrote const user new map at the top of your application, what happens if I restart the server? Everything disappears. Before restart, I have something like this. Restart node, now gone. Everyone gets fresh counter. What happens with multiple servers? This is where Redis exists. Imagine load balancer is there, API. It's each server has its own memory. They all have their own map. Not server knows what the others are doing. A client could effectively exceed your intended limit just by having requests distributed across instances. But same counter. Okay. How does the counter get reset? Participant. The library doesn't create one timer per client, that would be inefficient. Instead, it keeps track of expiration times and periodically cleans up expired entries. Conceptually, it's something like this. Okay, okay. Why didn't I see any headers in Postman? This one has a few possible video configuration. Okay, so let me actually see some headers. Yeah. Let me first run the project itself. So npm uh, cd backend, npm run start, and oh, npm run start. Okay, so I can let me first comment this out because Redis is gonna be annoying. I actually tried a Windows subsystem opening WSL, but is like didn't work properly for this hardware. Like the laptop is just too lazy, you can say. So let me hit this request. I think I have 15 rate limited, right? So let me actually make it 5. Yeah, and let's see what do we have got. This I think it should work. Internal server error. Okay, the client is closed. What does that mean? The client is closed. Client closed. Error. Okay. Um, Honestly, I don't really know what does this mean. Is that mean that my GWT has expired or something like that? Uh, or should I just move ahead? Okay. Connection. Okay, so Last person one comment is that you're trying to access the database from IP that isn't whitelisted. Make sure you can put this on your Oh man, this is the issue I really hate. I have to do this again and again. If anybody is watching stream, do let me know in the comment that how can I resolve this issue. Every time I have to do something like let's say login, I have to like put my IP every damn time, and I have been really tired of this shit. Well, anyway, the cursing words. Uh, anyway, let's see. Okay, this thing, this is what I'm talking about. I have to like give it in every time. Now let's see if it should see the. Okay, it's worked. Good. So now I can make requests. Okay, client is closed. What does that mean? Let me ask the AI. I am getting this error. Where does this coming from, and how can I resolve it? The stack shows the Redis client is already closed when you go to insert. Oh, okay. 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 So there must be something in my Redis implementation. Ah, this is one. This is my Redis implementation. Tell me where exactly it is. So the reason why it is like giving me error probably because of this line of code because your Redis client module is defined as a singleton, but the error usually appears when the same client instance get closed somewhere else. For example, in request level and then is reused. Okay, so my GWT, let's say this is my GWT. Client is being thrown from the line. Deny listed token. Okay. Oh yeah, I did implement something like this, right? And it's gonna get error because Redis client is not there. If I just committed this out, will this work? Listen, I need to check out. Tested myself. Fix. Okay. It's not defined. Okay, let's close this as well. One, two, three. Let me see the header if I'm getting. Okay, this one. So 5 in 1 minute, and I am having this express. Okay, I also want to use helmet chase for that, right? Right. Uh, to remove this X powered by. Actually, let me do this as well. If I have picked it up, MPI helmet, and in my index.js, let me use it somewhere around this, maybe this. App dot use helmet, and I would like to import helmet. Helmet. It's still downloading. Okay. Well, that's one thing. Uh, this is the count and this is the expiration time, right? And rate limit policy. Okay, so I didn't really check it here. Keep alive to 5 at send state. This is something e-tag and the content length. What does that exactly mean? I mean content length. Test result is cookie or just a body. Okay, so let me start the server again and actually use this. Okay, now, okay, the express header is gone. And let's see what other things I got. DNS the rate limit is there. Connection keep alive. Okay, so that means the helmet is working. Um, okay, okay, good. Looks good so far. Mm, so now let's move on to where we were. Okay, let's skip this person. Wait for your version. Blah blah blah. One thing I recommend before implementing starting video, rather than relying on expression limit, let's build the algorithm ourselves. Why? Yeah, why? Because then you will understand every moving piece, how the key is generated, how the counter is stored, why these commands are chosen, how race condition happen, why Lua scripts become necessary later. Yeah, actually, I have read this that Lua scripts are help with some atomic transaction and uh, generally it is a solution to like race condition happening. Okay, my suggested progression is build a fixed window middleware in memory using a map in about 30 lines. Replace the map with redis, incur, increment, and expire. Build a sliding window. Okay, okay, let's give it a shot. Let's give it a shot. Hmm. Although I have to like use this, but it's okay, I guess. Really, how I teach a junior engineer on my team, we are not going to build a rate limiter. We are going to build a series of increasingly parallel rate limiter, just like the industry evolved. We'll start with the simplest one possible, build fixed window memory. Mm-hmm. First, 26, identifier is IP address or request remind this IP, how many request has it? What data do we need? If a request comes in, what request do I need to know? I need to know who is it accessing my resources. Basically, the identification of a user or you can say a client. And I would like to know how many requests have been made by that client in the past 60 seconds. When does this window end? So we can define an object like counter stuff. Okay, now we can send sort of like overlook, insert update, store new map. So it becomes this. First question, what should be the key? IP, user ID, IP key, JWT. I mean, the key should be obviously an IP or a JWT. Uh, Now this is a hard question for now IP. Okay, it says right for now IP. Okay, next question. Suppose this IP has never visited before. What should happen? Empty, request arrives, then we reject? No, we should create an entry for that. Suppose the entry already exists. We first ask, has this window expired? Imagine the current time. This window expired. Should we keep incrementing? No, we start over. We reset the time. If the window has not expired, then we increment the count and we check if it has reached the max. If yes, yet this is our entire algorithm. Request arrives, get key like the IP, lookup map like our object store where we are storing all the counters. If there is no entry, then create one and keep the count to one and allow the resource to be used. If entry exists, then check if window expired or not. If yes, reset the count and then allow. If window is not expired, then increment the count. If exceeded, then give him a 4 to 9 error. No, then go to the next. What is something? This is not really a rate limiting problem anymore. It's just a state management problem. Yeah, exactly. That's pattern you will see repeatedly in backend engineering. Your task is I don't want you to copy a solution. Instead, implement it yourself with this constraint. Uh, like how do I do it? Okay, so it's give me a middleware. Let's say inside this middleware, I use fixed window rate limiter. I used sliding window middleware just okay. Fixed window create a middleware. Right, the algorithm we just discussed. Don't worry about being perfect if you get stuck, even halfway. Paste your code here. Okay, so let me first do this. Fixed window.js, and in what I would like to create a function fixed windows. It has something like this. Tracks. Since it's an like it just create a function launch fixed window window second to the number. Damn it. Okay, number. Then max request that can come right on with the rhythm we just discovered. Don't worry about being perfect if you get stuck even halfway. Please. After this, mm, is implement it yourself with this constraint. Okay, okay, okay. So I have this constraint that they have been talking about, and this is the middleware. So if if request comes in, IP found, then do this. Uh, if so has request.ip, then check. Uh, let's say if count is greater than max for that request.ip, then return 429 9. No, but before that, I have to first check if the reset time has hit or not, right? Yeah, I have to first check if the reset count, if reset time greater than if reset time is there, like how should I even compare reset time to what fixed window is there? That means 60 seconds. So if reset time is something like is around zero or it is found, then check if reset time is equal to zero or something, then call the next function. And if it's not, then if count greater than max, then call the next. each store doesn't has an IP. So what I would like to do is set this.ip, and I would like to call it next something like this. Don't worry about the being perfect. If you get stuck even halfway, paste your code here. After this, once it's working, we'll make it. So I created a file called fix window. Let's actually ask. So I created a file called fixed window. Yes, in my middleware. Also let me give you my GitHub repo for the project, which is this. Where is my URL shopping services? This one, middleware, a separate branch. I haven't published the branch as well, and this is the content of the file. It's nothing more than if else. I wanted to approach it. Attempt the implementation before looking at a solution. That's how you build an intuition. I also like that you are treating this as a real project instead of a throwaway file. We can evolve it branch by branch. Date limit, fixed window memory, fixed window ready, sliding window. Yeah, yeah, that's exactly like I want to work on. The number one problem, this is JavaScript. You are written TypeScript syntax. Your file is JS, but you wrote that only works in TypeScript. Since your project is JavaScript, it should only be like this. Uh, Later we can discuss using JSTalk if you want editor type hints. Nah, man, I don't really understand. Reset times are and count don't exist. You wrote reset time. Where does the reset time come from? What's inside the map? The map stores something like count and reset time. So the first thing you need is record request to IP. Now you have record.count and reset time. Those values don't basically exist as variables. Yeah, right? I missed it. Actually, rather than missed, I did something horrible. I should have used it. Record is equal to get the store dot get is dot IP. Now I have the record dot count. Okay. Okay. Those values don't. Yeah, yeah. Okay. Is incomplete. Map set requires both a key and a value. Very first request create. Later, user sends the first request. Should the map contain and an object like this, right? So your value isn't empty, it contains the initial state. You are checking reset time to zero. Think about what reset time represent. Is it as ever zero? No, it's timestamp. Instead, compare it with the current time. Ask yourself, has this window expired? That becomes current time. Reset time. Or compare with the reset time. Max should be max request. So you are referencing a variable that doesn't exist. You never implement the counter. Okay. So, uh, hmm. So you're referencing a variable that doesn't exist. You never increment the counter. Mm, Second request arrives. Your code says this. Next repeat. So the counter never changes. Window expiration doesn't reset anything. Suppose count 15. Window expired. What should happen? Note. Next instead count 1. Reset time. Now plus window premise. Starting a brand new window, here's how I think about it. Instead of coding immediately, think in terms of state transition. Uh, man, I don't really understand what he's trying to like say. Allow no increment. Ask if yes, so him. Don't read if you want to solve it entirely yourself. Like, mm, let's say your middleware can almost be written down this for operation. Now record store set. Everything else is just deciding which value to pass to this reset, right? So here it is my if request. One improvement before we continue. I just also should make the key configure from the beginning instead of hard coding like this. Design the middleware. Mm, Okay, actually, let me get back and try one thing at a time because my head is not able to keep up with all this information. So this is a TypeScript file. So let me remove all the TypeScript code first. Sorry, JavaScript. Yeah, right. So this one create become like this. So max should be my max request here. Yeah. Now where will my reset time come from? Is from record. And when will my count come from? From the record count. So I just don't want to store the record dot count. The initial, let's say record dot count should be start with the one and record dot current time, and I can just like do this like this. There you have it. New date object, something like this, right? Yeah. And I make something like this. Or is something wrong again? I think I removed this. Mm, record account. Set requested IP is incomplete. And set is this both a key and a value. So reset equals to IP. What should the very first request create? Uh, I got one. We're checking this time. If the reset time is current time, so have this window expired? Current time should be greater than request time, right? Reset time or equal to. Okay, it was other way around. I understood. So, generally, what happened is if my current time is greater than the record's reset time, that means the expiry has been done or like the condition has been made, something like that. If I have to put in the basic and simplest term is that we have reached the limit of the expiration time. So the next thing is gonna do is uh, create reset the counter itself. Reset the counter and action to max request that I did. You never increment the counter. Yeah, exactly. I didn't increment the counter. If else, is 1. We shouldn't just put down here. This operation doesn't need to do anything. So when the count is 1, then the reset time. Okay, the record reset time should be current time plus window ms. Okay, is that it? Is that it? Let me actually get back. Let me see what I got so far. So I let me have a smooth experience. So I do this. This is much better. The biggest improvement is that you are now thinking in terms of record instead of mysterious variables like count and visit time. That's the right mental model. Now let's do another peer review. I will point out the issue, but I still wouldn't give you the final information. Yeah, that's exactly what I want. First, let's simulate a request. Imagine this is the very first request. Store this. Request comes from the IP. Let's execute your code. Problem one is const record is most ordered, but since this IP doesn't exist yet, record is undefined. Later you do something like this. Yep, exactly. Can you see the issue? Record is undefined. Record itself undefined. Record, you don't modify an existing one. If I wanted to insert a brand new object into a map, what should the object look like? It will be an object literal. We said this time should be a time step and ask yourself, what does this produce? What's this date now? Or console log new date. Why don't I just see it here for myself? Console log. Are, okay, okay. That's really great learning experience right now. So all I have to date now, number for millisecond elapsed since midnight. UTC. Okay. Okay, I loved it. Okay, I fixed that, and this counter thing, it's the biggest logic bug. If current type is the next, let's think. Suppose count is 15, window expired. Should we simply call it next? No, it still contains counter. We reset the count. Should happen. Back to the loop that we said. Old window throwaway state create instead. Reset, not just allow. This line one or four. Yeah, right. So it should be added and and uh, uh, uh we reset it. Reset time should be 0. Should the reset time move on every request? It's now sliding. That's no longer fixed window. A fixed window. Okay, so I shouldn't be adding here this one. Sliding window there. Okay, okay. So understand. Problem 6. What happens if the user exceeded the limit? Okay, next responded. Then I can only say we like give him yes, any kind of error there. Wait, okay. At first, I is when writing middleware, instead of asking what should my code do, ask what are all the possible states. For fixed window, there are only three state one. No record, create one. Record exists, window expired, replace it. State 3, record exists, window still active, increment it. Reject, yes, no. Notice that every request must fall into exactly one of those states. Before writing any more code, grab a pen and paper or just type it out and answer the question. When exactly should reset time be assigned? Reset, like the reset time should be assigned when the current time is greater than this. Here, let me get it back. Do something experience backend just do instinctively. Model the state first, then write the code. Do for a fixed window, the state is tiny. So I'm heavily requesting for I think now it should be good to go, but I still see some issues. This is getting much closer, and I can see your reasoning evolving. You also had a really good observation. If I have a microphone that comes to decide what you are doing, right, is the only downside that isn't treated just by moving the reset time. It requires a different algorithm to really tracking time stamp, but your intuition that moving the window and son of it. Now let's repeat this as if you open VR, reporting to 0 is not starting a new window. Let's stimulate. Count 5. Should that request count toward the new window? So after the expansion, the state should represent this request is request 1, not no request and no request here. Okay, is it invisible button behind? Is it, I mean, it's not 60 second. Okay. I don't think. Okay, so I'm currently ending my stream here because it looks like I have to like first understand how to formulate the logic itself. So let me have that first, and then we'll continue back exactly where we left off. I promise on that.